Hey guys, today we are going to do some practice with the law of sines, and we're also going to see why using law of sines to find angle measures is a little bit tricky, and why we should, if we can, use the law of cosines instead. So on our opener here on number 1, we've got triangle ABC. And triangle ABC has angle A at 82 degrees, side B 12, and side A 3. Okay, now when we are looking for angles with the law of sines, we have to compare opposite to adjacent. So here is our angle. Opposite is 3, so I'm going to write here opposite and adjacent. Opposite is 3, adjacent is 12. And so opposite is less than adjacent, which means 2 possible solutions. Okay, so now I start to work on my solutions. So the first thing that I can possibly find is angle B, and that's because I've got a pair of opposites here, an angle opposite a side. And here's a side, I've got to use that opposite, so angle B. So 3 is to sine 82 as 12 is to sine B. Okay, so our cross products here are 3 sine B equals 12 sine 82. So we divide both sides by 3 to get sine B by itself there. So we've got sine B equals 12 sine 82 over 3. And then to get B by itself, we do an inverse. So B is arcsine 12 sine 82 over 3. So now we go to our calculator, and the first thing we should do is make sure we're in degree mode. And we are. So second sine 12 sine 82. Now notice it opened parentheses here. I have to close those parentheses and then divide by 3. Okay, and I get a domain error. When I get a domain error doing arcsine, that means it actually turns out that while I found that there would be 2 possible solutions, in reality, there is no solution. Okay, so this set of data cannot actually make a triangle. Okay, so now triangle DEF, where D is 82 degrees, E is 3, and then side D is 12. So notice it's almost the same triangle, except now the 12 and 3 have just swapped places. Okay, so we will compare opposite to adjacent. Opposite here is 12, adjacent is 3, so opposite is greater than adjacent, and greater than means fewer solutions, so 1 possible solution. Okay, so we will start out with the law of sines again. So 12 over sine 82 is equal to 3 over sine E. So our cross products are 12 sine E and 3 sine 82. Okay, so we'll divide both sides by 12 to cancel that out. And then do the inverse, so E is arcsine 3 sine 82 over 12. And that is 14.33. Okay, so it does say round to the nearest tenth, so when I put that right here, I'll go with 14.3 degrees. Here, just in case I have to use this again, I'm just going to keep extra decimal places. we'll call that 14.334 degrees. Okay, now if I need to use that in any further calculations, extra decimal places will be helpful to keep our answer more accurate. Okay, so to find F, we'll do 180 minus the two angles that we now know, 82 and 14.334. Okay, so that's going to give us angle F. And that gives us 83.667 degrees. Okay, so here I'll put 83.7 degrees. Okay, now a quick way to check is to do 14.3 plus 82 plus 83.7, and they come out to 180, so we know that our angles are going to be accurate. Okay, now last we need side F. Okay, so for side F, we do side F over sine of angle F, and I want to use the extra decimal places here, 83.667 equals, and then we'll use the ones that we know are exact, 12 over sine 82. Okay, now here all I need to do to solve this is multiply this across. So it's 12 times sine 83.667, and then that is divided by sine 82. So I get 12.0. Okay, and I want to keep the 0.0 even though it looks meaningless, but it tells me that my number wasn't exact. It was actually a rounded answer. So here I'm putting 12.0. And now I know all three sides and all three angles. And then triangle GHJ. Okay, so angle G is 35 degrees. Side H is 14 and side G is 12. So we will compare opposite to adjacent. Opposite is 12, adjacent is 14, so opposite is less than adjacent, and less than means more solutions. So there are two possible solutions. Okay, so for our first solution set, we will use the law of sines, and we can find angle H. Okay, so 14 over sine H is equal to 12 over sine 35. And then our cross products. So we get 12 sine H equals 14 sine 35. We'll divide by 12. And then we'll do arc sine. So H is arc sine. 14 sine 35 over 12. So we get 42.0. Okay, so our missing angle there is 42.0 degrees. Okay, so there's angle H. Okay, so now we can use that to find the other possibility for angle H. So we said there were two possible solutions. So we'll start on our second solution set. Okay, so we're going to take this 42.0 and find its supplement. So 180 minus 42.0. And we get 137.996, so 138.0. So there's our other possibility for angle H. Okay, so now we can find the third angle for each, so we can do 180 minus 35. minus, and this was actually 42.003, so I'm going to actually use those decimal places, 42.003, and this will help us find angle J. And we have 102.997. So here I'll put 102.0 degrees to the nearest tenth. Okay, then I can do the same over here for angle J. So I'll do 180 minus 35 minus, and then that 138.0 was really 137.997. So I get 7.003 degrees. So 7.0 degrees. Now, why do I want those extra decimal places? Because I'm going to have to use that in order to find side J. Okay, so side J. Now, you know what? I wrote 102.997, which really should have been 103.0 degrees here. Okay, so that's more accurate now. So I've got side J over sine 102.997 is equal to, and then I'm going to use the ones that I know are exact, 12 over sine 35. So I'll multiply that across. So I have 12 times sine 102.997 divided by sine 35. So I get 20.4. Okay, so that solution set is now complete, and I can find side J on this second possible solution. So J over sine 7.003 is equal to 12 over sine 35. So I multiply across. So 12 sine 7.003 divided by sine 35. So I get J is 2.6. Okay, so there is my second possible solution set. So now in example 3, we're going to use triangle WHY to find some missing angle measures. Okay, so angle W is 23 degrees, side W is 70, side H is 150, and side Y is 99.8. Okay, now this is a case where we could actually use the law of cosines. Unfortunately, in this course, we have not yet learned the law of cosines, so we're stuck with only knowing the law of sines. And we're going to find both of the two missing angles, and we're going to use the law of sines in both cases. So we're going to use the law of sines twice here. Okay, so for H, we would do 150 over sine H is equal to 70 over sine 23. So then our cross products are 70 sine H and 150 sine 23. And we can divide by 70 and then do the inverse. So H is arc sine 150 sine 23 over 70. So we get 56.85. Let's keep 3 decimal places, 0.854. Okay, then angle Y. So we have 99.8 over sine Y equals 70 over sine 23. Okay, so our cross products are 70 sine y and 99.8 sine 23. And divide by 70. So we get sine y is this expression, and then we can do the inverse. So y is arc sine 99.8 sine 23 over 70. And we get 33.853. Okay, but here's where we are about to find the problem. So we've got angles of 23 degrees and 56.854 degrees and 33.853 degrees. And that is not enough. 113.707. Okay, now a triangle needs to add up to 180. Okay, so how can we figure out what is actually correct here? So in this case, if I was to take the supplement of each of those two angles that I just found, so 180 minus 56.854 and 180 minus 33.853. So I get 123.146. And 146.147. Okay, now the correct angle measures are actually on this paper somewhere. So either I could use this angle here and add the supplement of this angle and the 23 degrees that was given, or this angle and the supplement of the other angle and the 23 degrees that was given. One of those two sets will actually give me 180 degrees. Okay, so let's start here. 56.854 plus the supplement of 33.853, so 146.147 plus 23, and I get 226.001 degrees. That's not good enough for a triangle. So we'll start with 33.853 plus the supplement of 56.854 plus the 23 that was given, and that gives me 179.999, which means because these numbers are rounded, it's 180. So we get our 180 from those three angles. So these are the three correct angles. Okay? Now we don't really want to have to do that every time we want to know the exact correct three angle measures in a triangle. So when we are given side, 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 which we were here, all three sides, or side, angle, side, which we were also given here, side, angle, side, we can use what's called the law of cosines, which we will learn about in the next lesson. The law of cosines will be accurate every time, and we won't have to jump through these kind of hoops to find out what the correct set of solutions is. So the conclusion is that finding angles with law of sines is possible, but it's dicey. What does it mean that it's dicey? It's risky, uncertain, unpredictable, precarious, unsafe, dangerous, perilous, high risk, hazardous, fraught with danger, stay away from it if you can. So what we should do is use the law of cosines for angles whenever possible. I'm ending that with exclamation marks because it's very important. Use the law of cosines for angles whenever possible. When is it possible? When the given information is either all three sides or two sides and an included angle. So when it's side, 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 or side, angle, side. And in our next lesson, we will learn how to use the law of cosines.